So the Math 3 Notes Unit 9, Section B. I'm going to introduce you to logarithms today. And last time we were together, we looked at the what power function. Okay, and so we had something like this: the what power base 5 at 25, and we saw that's equal to 2 because it was asking the question, 5 to what power is 25? Well, instead of using the word what power, we're going to replace that word with the word log. It's going to mean the same thing though. So instead of writing what power base 5 of 25, we're going to write log base 5 of 25. And everything's going to mean the same. So we're going to have 5 to what power is 25. We're going to get an answer of 2. Okay. And so that's one of the, on this lesson, really that's all we're doing. We're just changing what power to log. And from now on, we're not going to use the what power function. We're just going to use the log function in place of that, because that's more the standard function that's used. If you get a scientific calculator, you'll see the log button on your calculator. So this is what's really used in that. So I didn't start with log first because what in the world does log mean? That's why we started with the what power function, so you have an idea. We're finding a power to answer a question. Whenever you're working with logs, there's always an exponential form that goes with that, right? And that's what we have here. You have the log base 5, but here's my exponential form, the 5 to the power of x equals 25. And so that's what this diagram is showing here, that there's a direct relationship or different form for the same thing. You have the exponential form, n is equal to b to the power of p, and you can switch that to log form, p is equal to log base b of n. And sometimes you want one form over the other. So if I'm solving for an exponent, I want the log form, because that's the log's going to give me that answer. But if I don't want the exponent, if I know the exponent, I'm solving for something else, I may want exponential form. And we're more comfortable with exponential form too. So sometimes we don't understand what the log's asking. We can transfer it back over to the exponential form. And that's what we're going to practice first. So in this first example, we have a log form and an exponential form. What would the base be? The 5, the 125, or the 3? Those are your choices. The 5 is our base. Okay, so the base, you can find the base in the log, it's your little subscript, or the base in your exponential form is what's being raised to a power. Okay, now what's the exponent? 3. And again, in a log form, the exponent is the answer. In an exponential form, it's the exponent. Okay. So these first two problems are written in log form, and we want to change them out of log form into exponential form. Here we got log base 5 of square root of 5. Sometimes we put parentheses around this part, sometimes we don't. Is equal to 1/2. So we have these three numbers, the 5, the square root of 5, and the 1/2. And we want to rearrange them to create an exponent. So what's the base? What's the exponent? And that's equal to square root of 5. Does that make sense to you? 5 to the 1/2 is square root of 5? Yeah. And doing the same thing with the log base 3 of 1/9 is equal to -2. What's the base? 3. What's the exponent? And 1/9 is the last part. Is that true? 3 to the -2 is equal to 1/9? Yeah. So because if we had 3 to the -2, that would mean 1 over 3 squared. And 3 squared is 9. Okay. Let's go the other direction now. We have the exponential form. We want to get the log form. So on 2 to the 5th power equals 32, we'd write log. Our subscript would be 2. What would we plug into this function? 32. and our answer would be our exponent 5. Okay. In this one, we got log. Our subscript, or our base, would be 10. We'd be plugging in the 0.001, and our answer would be the exponent -3. So these first problems are like what we were doing for homework before. The only difference is they have the log here instead of what power. And so if you're finding log base 6 of 216, you're asking the question, 6 to what power is 216? What power is that? 3? How'd you know that? You just tried it out, or you knew it already? Lucky guess. Well, you just try out powers of 6. You guys know what 6 squared is? 36. We know that one. You may not know 6 to the third, but you can find it by going 36 times 6, right? 6 times 6 is 36. 6 times 3 is 18, plus 3 is 21. So 216, so you know 6 to the third is 216. So what's our answer? 3. Okay. Log base 4, 256. What's that going to give us? Thinking 4? Okay, to check that, we can change it to exponential form. That would mean that 4 to the fourth is 256. Is that true? And if you don't know, try it out. 4 times 4 times 4 times 4. That would be 16 times 16. And if we multiply that out together, so 16 times 16, 36. So 256 is what we get. That works. So 4 is our answer. Okay. Easier one here. Log base 5 of 1. Braden, we think that answers it. Log base 5 of 1. What do we get? Well, as an exponential form, what's it asking? This is 5 to what power equals 1? This is a question here. Okay. So this is what I mean. If you get it out of log form into this exponential form, sometimes it makes more sense because we're learning what the log form means. We want to get the exponent by itself so we can eventually solve for it. Okay, this one's not solved for x. This one is. Log base 2 of 1/4. Colton, what do you think? 1/2. Okay, let's check. So this is asking 2 to what power is 1/4. If you ever have a, if your base is not a fraction and you're getting a fraction as an answer, that tells you what about the exponent? It has to be negative. Okay, so we need so what are you going to say? -2. Because 2 squared is 4, but to get that fraction, it's going to have a negative. So 2 to the -2 is what we want, because that would be 1/2 squared, 1/4. So -2 is our answer. Next page, we're doing the same thing. Log base 7 of the cube root of 7. Alyssa, what's that going to equal? Okay. Okay, what's the question in exponential form? Good. Yes. Okay, so if you have if your base is an integer and you're getting a root, like a square root or cube root, you're going to have a fraction as an answer. Okay. This next one, it looks a little different here because it's missing the subscript. The 10 to the fifth is what's being plugged in, but we have no subscript here. And if we don't have a subscript there, by default, it's a 10. Okay, we call it a common log. Our whole number system's in base 10, and it's used a lot. And so by default, if we don't write a number there, it's 10. So there's two logs that come up a lot, and actually you'll see this on a scientific calculator. Either see the log button, or the other one is the ln button, which we call the natural log button. And let me just show you that for real quick. All right, so here we have our log button. By default, that base is going to be 10. Okay, and then here's right above it, we see the ln button, which we call the natural log, and that has a base of e, which may not be a number you're familiar with, but it's right over here. You'll see that also on a scientific calculator, and it's like the number pi. Pi you've used a lot, and it comes from circles, right? It's actually defined as your circumference divided by the diameter of any circle gives you this ratio pi. E is another irrational number like that. We call it a natural number because it comes up a lot in the sciences or in financial equations, those kinds of things. The number, here's the approximation of that number. It's always that, 2.718. So when I use the natural log, the ln, the base is this number e. And instead of writing all the decimals there, we're just going to use the letter e, which is easier to write. Okay. So let's jot that down in our notes here. So ln means log base e, and then the natural log, or this, if it just has log without a base, that would by default mean log base. And those are the only two that are out there. Those are the only two you have to memorize. Okay. So back to this problem here. We don't have a base, so we're going to use base 10. And now we can answer the question. Jake, what's the answer to that question? What's the log of 10 to the fifth power? It would just be 5, because this is asking 10 to what power equals 10 to the fifth power? The answer is 5. Okay. Natural log of square root of e. Jaron, what do you think? Not sure. So ln, first of all, means log base what? E. So we got log base e of square root e, and that may be helpful for you to just change it to that form. It means the same thing. And then that's asking what question? E to the what power is equal to the square root of e? What do you think? What do you think now, Jaron? Is it easier now to 1/2? Once you get to that, then it's a little easier to see. Okay, we got if we get a square root, that would be the 1/2 power. And then we got natural log of 1 over e cubed. Christian, what do you think? -3, good. Because this means log base e of 1 over e cubed, which is asking the question e to what power is 1 over e to the third. Well, e to the third power is e to the third power, but we have this fraction, and to get that fraction, you got to have a negative in there. So the negative third power. We're going to pause here, and if you look at the first page of 9.2, worksheet 9.2, 1 through 20 are like this, and so I'm going to give you some time to work on those. Okay. Next, I want to talk about approximating logs. Okay. So there's a little example that I'll walk through. And if we start with trying to find the log base 2 of 10, and you say, well, what does that mean? That means, well, 2 to what power is equal to 10? We don't know that, right? 10 is not a power of 2, and so it's not going to be a nice, easy answer to come and get. So we can approximate it. Okay, we could say, well, and you have over here 2 to the third power is 8, 2 to the fourth power is 16, and 10 is between the 8 and the 16. So if we're looking for the exponent that's going to give us 10, it's going to be between 3 and 4, 3 point something, right? And so that's what we do. We write our answer somewhere between 3 and 4. And you want your integers to be consecutive. You don't want to say, well, somewhere between 1 and 100. Right? You want to narrow it down as best you can. So consecutive means one right after the other. And so that's what we're looking for. So log base 3 of 25, that's asking the question 3 to what power is 25? 25 is not a power of 3, but I want to get as close as I can get to it using an integer. And I want to get as close as I can get and get something below 25, and then something as close as I can get but above 25. So 3 to the power of 2 is 9. 3 to the power of 3 is 27. And so we have our consecutive integers, 2 and 3, and where 25 is going to be between those two answers, the 9 and the 27. So our answer would be x is going to be somewhere between 2 and 3. Okay. Somewhere between 2 and 3. And I'll take so log base 7 of 9, asking the question 7 to what power is 9? We know 7 to the first power is 7, 7 to the second power is 49, and 9 fits in between those two. So our power is going to be between what? Between 1 and 2. And then log base 3 of 200, that's asking the question 3 to what power is 200? So we start listing our powers of 3. 3 to the 1 is 3. 3 squared is 9. 3 to the third is 27. 3 to the fourth is what? 81. 3 to the fifth is 243. And you could stop once you pass the number you were after, right? And so 200 is between 81 and 243. And so our answer is between what? Between 4 and 5. Now, it's not in your notes, but it's something that we're going to want to go over because it is in your homework. And so I have a problem that I want you to think through with me, because this actually tends to be the most complicated of all the problems. And but it's an application. And if you're in chemistry or you were in chemistry, you may have heard of pH levels. Yeah? Okay. Did you know it's a logarithm? Right? Also, you may have experienced an earthquake, right? And they give a number to that earthquake. That was a 3.2 or 4.57. Those are logarithms that they're giving you. Okay. Those are a couple applications to that. But pH level. A pH level is defined as negative log of H, where H represents the concentration of hydrogen ions in a solution. And so we're given the concentration of hydrogen in what we call scientific notation. You guys familiar with that? No? Okay. And then we're going to plug that into our log equation to find the pH. But we're going to do this without a calculator. So we're going to approximate. We're going to say it's between this and this, okay? And then we're going to classify it as either basic or acidic. And the classification is this. If the pH is less than 7, it's considered acidic, right? Greater than 7, it's considered basic. So let's take a look at vinegar. So vinegar has a hydrogen level of 1.2 times 10 to the negative 3. Okay. So the way I'm going to have you do this is take it out of scientific notation first. So if you have the 1.2 times 10 to the negative 3, to get it out of scientific notation, you're going to take this decimal and you're going to move it. I'll put zeros over here. You're going to move that decimal place 3 times, right? So 1, 2, 3, it ends up right here. And so we end up with 0.0012. Okay? How many decimal places in this number? Okay, so it's going to be important to note that. Then we're going to compare it with powers of 10 because remember, this log has what base? If we don't write the number in, it has base 10. So as a decimal, what is 10 to the negative 1? It's 1 over 10 as a fraction. What is it as a decimal? 0.1. What is 10 to the negative 2? Which is 0.01. 10 to the negative 3, hopefully you see a pattern here. 0.001. 10 to the negative 4. Right? Okay. And with a decimal, okay, usually you stop when there's only zeros after that, right? But we could add as many zeros as we want after if we want to extend it. Right? You're allowed to do this. It doesn't change the value. So if I want to make a comparison is find out, okay, that 0.0012 is between which of these numbers? Right? Because this is 4 decimal places, I'm gonna look at the first 4 decimal places of these. So there's first 4, Okay, because we're working with 4 decimal places. And then it's a little easier to see, well, which one is this in between? Can you see it? You can think of this as 1, 10, 100, and 1,000. And think of this as 12. Well, 12 is going to be between 10 and 100. So this is going to fit right in between these two. Okay? So we're asking the question, 10 to what power is 0.0012? And we're going to say x is between what? Between -2 and -3. You guys following me so far? Okay. Now, look at the pH. The pH is this. The pH is negative log of h. So we found log of h. Log of h is between -2 and -3, but then there's a negative out in front, which is going to change our signs. So our pH is going to be between 2 and 3. And that's what we'll write in here. So is that classified as basic or acidic? Acidic because our pH is going to be below 7. I think you know that vinegar is going to be acidic, right? Okay, let's try it one more time. Why don't you try it with baking soda before I do? See if you can get it right. Okay. Okay, let's take a look at baking soda now. Did you guys get an answer? Between what and what? Not sure? Maybe, okay, let's check. So first, they tell us the hydrogen level or concentration of hydrogen in baking soda is 2.4 times 10 to the -8. So your first job is to find out how many decimal places this is. Okay, and so I need to take that decimal place and move it 8 places to the left. So if I have, I'm going to put a bunch of zeros here. 1, 2, 3. So I have a decimal place right here, and I need to move it 8 places. So 1, 2, 3, 4, 5, 6, 7, 8 right there. Okay. So this is going to become 0. And I count 1, 2, 3, 4, 5, 6, 7 zeros. And then a 2 and a 4. And what we need to get from this is ask ourselves, how many decimal places is this number? How many decimal places? How many? All you need to do is count. 9. We got 9 decimal places. Okay. Then we're trying to find out 10 to what power is equal to this number. And so we need to think about, well, powers of 10. And, well, if I want 10 to the -5, that would be how many zeros? No. 4 zeros and a 1. If you go down the pattern, if you need to, start at 10 to the -1 and get here. But 10 to the -6 would be, so this is 5 decimal places. I want 9 decimal places. I got to do a little work here, right? That's 7 decimal places. This would be 8 decimal places. And I'm going to stop here, though. Okay, if these are, we can add as many zeros as we want after the ones. Because I'm working with 9 decimal places, I want to look at the first 9 decimals. Really, those are the two that I want. Because this is like the number 10, this one's like the number 100, this is like the number 24, which is going to be between these. So x is going to be between -7 and -8. Good job. So our hydrogen, or sorry, our pH is negative log of H. And we found log of H. So if I multiply by negative, I get a pH of between 7 and 8. So it's between 7 and 8. What do we classify that as? Basic. Okay. Right. All right. Question on that part. All right. Last part of the notes is on finding the y-intercept of a couple functions. Eventually, we're going to be graphing these log functions, and we're going to want to find these pieces. To find a y-intercept in any function, what do we do? We solve for y when x is equal to 0, because on the y, any point on the y-axis has a x value of 0. So we're going to set x equal to 0 and solve for y. Okay. 0 plus 9 is 9, so this is y equals log base 3 of 9 minus 1. What's important for you to realize is that minus 1 is not part of the log. So you're going to have to evaluate this log first, find out what that's equal to. Whatever you get as an answer, you're going to subtract 1 from it, and that will give you your y-intercept. So what question is this asking the log base 3 of 9? 3 to what power is equal to 9? And what's your answer? 2. So this is really, what's 2 minus 1? And so our y-intercept is 1. Okay? So find the y-intercept of log of x plus 1 plus 3. What are we getting? We got to find log of 1. There's no indicated base, so what's the base? 10. So it's asking the question 10 to what power equals 1? And the answer is 0. So this is y equals 0 plus 3, which is 3. Okay. Again, I'm going to pause, give you some time to work on your homework, and then we got one more part to look at. So on here, we're gonna now talk about solving for exponents. The focus is still in exponents. We're not going to write the word log here though, because we're gonna be able to solve it without logs. Some problems we can with sometimes we don't need the logs, sometimes we do. Okay. But just to remind you, got my lucky log here, and my base. Okay. Actually, they're gifts from other teachers. Okay. Okay. So here's what we need to do to solve these, if we can. Okay, and these will work out for us. We want to follow these steps. We're going to rewrite each side of the equation to have the same base. Okay. So we're going to look at the 4. We're going to look at the 32. And we're going to decide which should the base be, so that they're the same. Is 4 and 32 a power of some number out there that they share in common? What? Well, we need to figure that out. We need to know our powers, and really, we only need to know powers of 2 and 3 and maybe 4, maybe 5. We don't need to know too many numbers in terms of powers. So 4 is a power of what, and 32 is a power of what? 2. Okay. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. 2 to the fourth power is 16. 2 to the fifth power is 32. So we can change our 4 and change our 32 to 2 to some power. So 4 is going to become 2 squared. But notice we had 4 to the power of x. So we had that x already there. So I'm going to multiply my new power with the x. So now it's 2 to the power of 2x. Is 1 over 2 to the power of 5. Okay? I'm working on getting it the same base. I have a fraction here. I want to get rid of the fraction, so I could rewrite 1 over 2 to the fifth to 2 to what power? Negative, right? The negative goes with the fraction. So this is really 2 to the 2x is equal to 2 to the negative 5. Okay? What we just did is step 1. Okay? That's step 1. What's step 2? Drop the base, right? All right. We did step 2. Okay. What's step 3? Find x. So x is negative 5 over 3. Or 5 over 2. Hopefully the teacher below me doesn't get upset here. Okay. All right. So that's what this is like, okay? So this next one. Step 1, get a common base. What should the base be? 2. Because 2 is a power of 2. That's 2 to the first power. 8's also a power of 2. That's 2 to the third power. So we got 2. We're going to leave this one alone. And then second step, drop the base, but I won't do it this time, all right? So we got negative x plus 3 equals 3. I'm going to distribute, add 3, and multiply by negative 1. What do you mean? Which line you're looking at? Yeah, so when I drop, the base is the 2, right? So I'm getting rid of the 2's, and I'm setting my exponents equal to each other, okay? And then once you get there, you got to solve it. Okay, so you try it. 9 to the x plus 2 equals 3. Try that one out. Again, you're modifying your notes here a little bit to match mine, okay? So this would be the third problem. 9 to the x plus 2 is equal to 3. Even sign Mr. Everly. And this is from Mr. N.
Cross out if you cross out one that you write it out. And if you need 47 is a power 3. Yeah. And
Sorry. It's all right. Yeah. Yeah, you could. It wasn't the way I was thinking, but it works. I was thinking of making the base 3. I was going to change that to 3 squared, but this works too. Keep solving, you'll get the right answer. Okay. All right. So, what base are you choosing on this one? Okay. I've seen both. I saw 3 and I saw 9. You can do both, and I'll show you both. So if you go I think most of us chose base 3, and if you do that, you're going to change the 9 to 3 squared. But be careful. When you change it to 3 squared, that new exponent, that 2, you're going to have to multiply with the old exponent, the x plus 2. And I have to put the x plus 2 in parentheses because I'm going to distribute that 2 to both parts. Okay? And that's equal to 3 to the power of 1. So now when your bases match, then you can assume that the exponents must be equal to each other. And so I could ignore the bases or drop the base and write 2 times x plus 2 is equal to 1. Or 2x plus 4 is equal to 1. You see it? Ask those questions. It's good to ask. And so you end up with x is negative 3 halves. Now, if you made 9 your base, you'd write 9 to the x plus 2 power is equal to 9 to the what? 9 to the half, because the square root of 9 is 3. And some of you did that, and that works as well. And so you have this equation, x plus 2 equals a half. So x is 1/2 minus 2 over 1. And I multiply top and bottom by 2. You get 1/2 minus 4 over 2, which is negative 3 over 2. So very different ways to do this. Both work. Okay. Try the next one. 49 to the power of 3x is equal to 7 to the power of x minus 1. And this one, our common base is 7. So change 49 to 7 squared. And you're going to multiply that 2 times the 3x that was already there. So 7 is our common base, so we can set our exponents equal to each other now. Two times 3x is 6 times x. I'm going to subtract x from both sides and get 5x is equal to negative 1. And then divide by 5. Got two last problems to try. Try 10 to the x is equal to the square root of 100,000. And 5 to the x minus 1 is equal to 25 root 5. Okay. What did you guys get on this one? 10 to the power of x is the square root of 100,000. X is, yeah, I'm going to definitely do it. Definitely. But anybody get an answer? What? 5 over 2 is what we want. And here's how. So first thing that I would do is rewrite. So if you have a 1 with zeros, that's 10 to some power. And you just count how many zeros you have. 1, 2, 3, 4, 5. So this is 10 to the 5th power. Okay. Then you have two routes you can take here. You could say, well, let's get rid of the square root by squaring both sides. And so you get 10 to the 2x equals 10 to the 5. And then you say 2x equals 5 and divide by 2 and get it. Or you could remember this is the same thing as 10 to the 5 over 2. Because 5 is the power, and this is a square root. There's a little invisible 2 here, right? That's your root. And as a fractional exponent, that's the denominator of the fraction. And so then that's a quick way to get to x equals 5 over 2. And then the last one's even a bit trickier. Anybody got an answer on that one? You can tell what the base should be. What should it be? 5, right? So 5 to the power of x minus 1 is equal to, can we change 25 to 5 to some power? 5 what? 5 squared times square root of 5, that's 5 to the half. Okay, that's your starting spot. Okay, the first thing to do. Get everything in terms of base 5. But then next, we need to multiply the 5 squared times the 5 to the 1 half. When you multiply those together, what do you get? You get 1. Oh, you're multiplying the 2 and the 1 half together? What's the rule with exponents, though? If the bases are the same, you actually add the exponents. And you guys know that if I had x squared times x to the 3rd, that's x to the 5th, you add the 2 and the 3. That's what we're doing here. We're adding the 2 and the 1 half, which, well, what's 2 plus a half? 2.5, yes, but 5 over 2 is better to write it as a mixed, or it's not a mixed fraction, but an improper fraction. So this is 2 over 1. I'm going to multiply top and bottom by 2 to get 4 over 2 plus 1 over 2. So we end up with 5 over 2. So 5 to the x minus 1 equals 5 to the power of 5 over 2. Now we can set our exponents equal to each other. I'm going to multiply both sides by 2 and get 2x minus 2 equals 5. I'm going to add 2 to both sides and divide by 2. So you get 7/2. Okay, so homework is to finish all of 9.2 and to do 1 through 12. Only 1 through 12 on 9.3.